Alright, this is a quick overview of a robot platform I am working on. I do not have a drivetrain quite built yet. I know what I have an idea of what I'm going to do, but I thought that since I'm going to need a controller, system, and sensors, I might as well start with that because I have the hardware and I know this is going to take a lot longer than the actual construction of the robot to write the code and get it actually functioning. So, as the brain, I have an OSEP clone of the Arduino Mega. It's pretty much the same as a regular Mega, except it has a USB micro USB port and a Molex connector for certain proprietary I2C sensors or circuits or whatever you're going to attach. It's kind of useless, but I may find use for it as it actually has not only the SDA and SCL line, that you can't see them, but it also has power and ground. So for breakout purposes, that may come in handy someday. Alright, next we have a Maxsonar EZ1 ultrasonic rangefinder, which I have found to be pretty accurate. I mean, I haven't had a lot of time to actually run it on a platform that's moving, but given what I've tested it, range-wise, it seems to be accurate, almost 100 inches, so that's pretty good. Then I have a Bluetooth module from some Chinese company. There's so many of these that you can pick them up for $10 at goodluckbuy.com. That's where this one came from. Then we have a C3-370C GPS from Jam, or I don't know, J Comco. I don't have much experience with GPSs, but this one seems to work fine. Picks up the satellites in a matter of seconds if it's not too long since you turned it on last. It has a nice battery that allows it to remember where it was last, so getting a GPS fix is faster upon boot up. Next we have the ADXL345 3-axis accelerometer with tap detection, free-fall detection, and interrupts. And I believe I have a post on my website using this to turn on an LED a different color depending on how many times you tap the board. Next we have a gyroscope. Now my original idea was to use this to try to track the heading of the robot, but obviously it sort of works, but if you know anything about physics and dynamic equilibrium, you realize that an accelerometer, because it only measures acceleration, completely ceases to function as a location tracker once you have reached dynamic equilibrium, which is, it's a state that's not physically achievable, but you can get close enough to it that it throws off your measurement too much to be viable. So at the moment, this really isn't doing anything. I'm getting the raw data from it, but I'm not really using it. For the sensors, that's it for now. I'm going to have a compass module to replace this, so I always know which way I'm pointing, which will help with, preset movement or the reference angles or whatever I choose to do with it. Other than that, there aren't any more sensors, just a speaker I ripped out of a electronics kit. And that plays a startup tone when I reset the board here, so if you're familiar with Arduino code, it runs a startup before it gets to the run startup. It's called void startup. It runs that before it actually starts the loop. So I just have it play some tones. It's a little chunk of code I wrote myself when you start it up. Now I'll see if you can hear this. So if I reset, I don't know. Let's try that one more time. I don't know how good the microphones are on this. There you go. If you didn't hear it, you didn't miss out. It just makes a few beeps. If you notice this strange bank of capacitors, I was having issues with lots of noise on my power bus, and that was throwing off this, which is an analog sensor, not a digital sensor. So I didn't have any inductors, so I couldn't build a proper filter, and I knew that if I put capacitors across the power supply, it might help smooth it out. Didn't help that much, but it was enough for me to leave them there. And I didn't have quite the right types for the frequency I was trying to filter out, so I just put a ton of them in there. And it helps a little bit, but it doesn't really matter at this point. Because my next sensor, I won't have any analog sensors that will be prone to be affected by noise on the bus once I get rid of this and replace it with a compass. So next, well, let's look at the Arduino code. At the moment, I just have the main sensor integration page with some GPS functions. Mainly the only thing I can tell you at this point, I haven't released the code yet because it's really not ready. It's not functional for driving anything. It mainly just reads sensor and sends it to my computer. But so far, these are the libraries I'm using. This is one for the Gyroscope, which, by the way, is the ADW22307. That's what it is. And this is a library I wrote. This is the library I wrote to run the accelerometer. This is the standard wire library from the Arduino. This is a library I wrote to run the sonar. Let's wait for it to focus again. Come on. Come on. There we go. Pitches is just a bunch of lists of frequency that made nice sounds when I ran them using the tone function. And Tiny GPS is a huge GPS open source library that I use to communicate with my GPS. What is up here? This is just the standard C library that allows me to do a lot of string functions that may not be included in the standard Arduino library. And this is my definition.h file, which is just a tab up here. We'll go to. And this is where I store initialize all my variables and constants and flow control. Mostly just a declaration of stuff, some tones, and some strings. That's it. Now the interesting part is, I believe I already have it running. So it's running. As you can see, it is currently transmitting data. There we go, along serial to the computer. And I've used processing, which, if you don't know, is what the Arduino integrated development environment is based off of. It's from MIT. And here it is. It's very useful for drawing GUIs because it was designed for graphical purposes. As you'll notice, it looks exactly the same as the Arduino, except it's gray. And the syntax is almost exactly the same. It's different in several places, like you have to actually import the serial library, and you can't use definitions because this is real Java, like a pound definition than numbers. But it is very useful for this. So this is just my preliminary GUI for the robot data feed because it's better to look at than raw numbers. Up here, we'll wait for this to focus. I have the date and time from the GPS. I have the latitude and longitude, altitudes, and speed, all from the GPS, and the number of satellites it's currently communicating with. The heading is meaningless at this point because the way I was using the gyro, as I mentioned earlier, doesn't work. So that's currently the raw data from 0 to just an analog read data from the Arduino. So you'll see that it's about 2.5 volts, which is, half of the 5 volt supply, so that means the gyroscope is not moving. So it'd be if I wiggle the gyroscope, you'll see that number will change a lot. Now the range, 16 inches, is from the this is irritating, from the rangefinder, the ultrasonic rangefinder. And once I get this thing to focus here, if I am to move my hand up and down, you'll notice that it measures that. Now the interesting bit. This is just left over from a certain thing I had before. Right now it's just representing the gyro acceleration. But here's the really interesting thing. So it's maybe easier to see if I do this. Make it look like an axis. No. Hold on. There we go. Okay, so each of these axes is an axis on my accelerometer, and I just used some trig so it would print them out in color along a sort of Cartesian plane axis looking thing. And you'll see that when I wiggle it, they move. If I turn the gyroscope upside down, the blue, if I move it along the x-axis, you'll see that that goes, and the same is true for the z-axis, obviously. That's my favorite piece so far. Doesn't really serve any purpose, it's just kind of cool looking. And that is about it so far. I plan at this point to run mechanism wheels using through some continuous servos from SparkFun for the actual driving base. I have a nice piece of Lexan. Actually, I'm not sure if it's technically Lexan. It's just a plastic, I think it's a 1/4 inch plastic, which I'll be using as the body. I'll attach the 4 servos and 4 mechanism wheels, and we'll go from there. I'll attach sensors. I may get another 2 or more of these guys so it can see in all directions, and then I'll just have fun with, behavior, maybe setting it with some moods, driving patterns. Maybe you can chase it and it will try to, if I have 4 ultrasonic sensors and I put them each on one side of the robot, then I may have it write some code that will cause it to drive to the position where the distance from all other things it's measuring is equal. So maybe you could chase it, it would actually run away from you because it would try to equalize distances. But this is all theoretical. I've still got to actually do it. But for now, this is a demonstration of what I've built so far. And I will update more and release the code once I have removed the majority of the bugs.